The Dalai Lama preaches that with realization of one's own potential and self-confidence in one's ability, one can build a better world. In my own opinion, telling someone that they never achieve their potential is one of the harshest things that you can say to another adult. We typically aren't so rude to someone's face, but there are few of us who haven't silently passed judgment on those who have unfulfilled potential. The vast majority of this planet's inhabitants believe that we only get one chance at life. Remaining in your mom's basement watching others live their lives through social media seems a unique form of hell for those of us who do in fact feel as though we are at least meeting our potential, if not maximizing it. For those that chase their potential, fully going for it despite all of life's roadblocks, author Noreen Romru reveals the greatest story anyone can tell is the story of their life. Just don't let the climax of your story be unrealized dreams. Albert Einstein is one of those who not only had potential, but was, in the words of historian Ronald Clark, uniquely poised to change the world as the extravagant timing of history linked him with three shattering developments of the 20th century: the rise of modern Germany, the birth of nuclear weapons, and the growth of Zionism. Most of us would say that he was the man needed for the moment, while readers of Robert Jordan's landmark fantasy series The Wheel of Time would say that he was woven into our society by the pattern at the precise moment that he was needed the most. Yet Einstein, at this point in his life, primarily represented unrealized potential. So much so that his early mistakes were only going to make his life's journey significantly more difficult. You're listening to Empires, Anarchy, and Other Notable Moments, a podcast designed for deep dives that assist in the teaching of history. This series is about the man who remains synonymous with the term genius, Albert Einstein. Episode number 2, It's All Relative. Having been expelled from his school in Munich, Albert Einstein, a German secular Jew, joined his family first in Milan and then later in Pavia. Among the jobs that the elder Einstein completed during this time includes work on an electrical plant that has now been turned into a residential center, as well as a water mill that was rebuilt in 2020 in order to once again produce cheap electricity for northern Italy. His son's expulsion from school was obviously disappointing, resulting in him repeatedly urging Albert to forget this philosophical nonsense and apply himself to the sensible trade of electrical engineering. It was wise advice, as the lack of a gymnasium diploma literally barred entrance to 99% of Europe's extensive network of universities. Rather than applying himself, however, young Albert treated his time in Italy as a gap year experience, traveling to museums and reveling within the high culture of Italians. At the heart of all motivational quotes is the concept that it isn't how many times you get knocked down, it's how many times you get back up. There remained just one path available for Einstein to have a chance to have his mind shaped by the scientific experts of his era. The Federal Polytechnic School in Switzerland's capital of Zurich was among the 1% of universities that didn't require a gymnasium certificate. Despite being 2 years younger than the typical applicant, the 16-year-old Einstein made the decision to apply. Before leaving home for the critical entrance examinations, Albert sent off a paper to his uncle that he had been working on in his spare time. The ideas contained within the 5 pages of the lined paper bearing the title of Concerning the Investigation State of Aether in Magnetic Fields contained the outline for what would become Einstein's Theory of Relativity. At this point in time, the paper only asked questions, which, considering that he was just 16 years old, is perfectly fine. But the questions that he had chosen to wonder about aloud had never been asked. The question stemmed from Einstein's discovery of a paradox that came about by asking what would happen if one could follow a beam of light at the speed of light. His uncle didn't have the answers either, and thus we'll put a pin in that question for the moment. One of my favorite coaching lines is that hard work beats talent when talent doesn't work hard. Einstein had failed the entrance exam, wasting what seemingly amounted to his final chance at avoiding the fate of working in the shadow of his father's company. I use the term waste because he would later recount that the failure in Zurich was entirely his own fault because he had made no attempt whatsoever to prepare himself. When taking the praxis, the required test for a teaching license in the US, I at least had enough foresight while we were waiting to go in to ask the girl standing next to me how to divide fractions. Late is better than never. The lazy habits that had developed during Albert's time at the gymnasium had unfortunately come back to haunt him. He was, of course, absolutely crushed. But it turns out that Einstein had a guardian angel looking out for him. The principal of the university had been impressed by the 16-year-old's math scores, despite the fact that they weren't large enough to make up for his deficiencies in zoology, botany, or modern languages. After all, French had always been his lowest scores back in Germany. The headmaster quickly arranged for Albert to attend a school 20 miles away in hopes that a year's worth of proper schooling would boost the young man's scores to the requisite level. One would expect Albert to make the most of his second chance, but rather than a perfect obedient student, the German boy was described by those who knew him during this time as imprudent, full of himself, sarcastic, bitter, intellectually disinclined, and prickly arrogant. Clearly, his tough outer shell wasn't quite ready to be cracked in just a year. Still, this school managed to open his eyes to the beauty of education. Rather than rote memorization, he had been invited into a world of university-styled lectures where questions were encouraged. His mind began to expand as he learned science while hiking in the Alps on regular class field trips. The differences were so severe that he made the fateful decision to renounce his German citizenship once and for all. This wasn't something that he could have done on a whim. As a minor, only his parents could take such an action on his behalf. After much badgering, the deed was done, and Albert Einstein ceased to be a German citizen on January 28, 1896. Becoming what was then known as a stateless individual. He followed this decision up by renouncing Judaism. Repudiating his family's religion turned out to not require any forms. That was merely something that he confidently announced to his parents. Cocksure of himself, the 16-year-old was convinced that he knew better than everyone else within his orbit. We unfortunately don't know the inner thoughts of his father on any of these matters, but I imagine that they weren't all warm and fuzzy towards his son, as it took some convincing from his mother's extended family to underwrite his second attempt at getting into the Polytechnic school in order to pursue a career in teaching. This time he passed, sentencing him, in the words of Clerk, to a 4-year course which would, if he were successful, qualify him for a post on the lowest rung of the professional teacher's ladder. Albert Einstein wasn't too stressed out by college life, with Clark referring to it as conventional enough. There was the fairly frequent change of rooms, the frugal diet of restaurants and cafes, supplemented by snacks from the nearby bakery or from kind Swiss landladies. There was a weekend outing to one or more of the minor summits surrounding the Zürichsee, the Swiss version of the reading parties in the Lakes or North Wales, which were a feature of the Victorian scene in Britain. Einstein was casual of dress, unconventional of habit, with the happy-go-lucky absent-mindedness of a man concentrating on other things, which he was to retain all his life. He enjoyed the attention of ladies, positively oozing the charisma that he would maintain throughout his life. But he wasn't a scoundrel by any means. Although it is well known that he surrounded himself more with women than men, most historians believe that he already viewed relationships with the opposite sex as a distraction from his work. Plus, as his second wife would confide with the press, intellectual women weren't his preferred type, as the young man preferred someone more like his mother, which she described as peasant stock. The work that he was focused on wasn't his assigned classwork, as more than one professor caught him daydreaming in their class. Harman Minkowski, a famous physicist in his own right, would later describe his most famous student as a lazy dog who never bothered about mathematics at all. That is a damning statement, as Einstein was in school to learn how to be a mathematics professor. I hope you're picturing a young Albert with his plump cheeks and round chin staring off into the distance, daydreaming about Eastern European peasant girls. But rather than that delightful thought, he was working on devising answers to the scientific questions that remained bouncing around in his head. He maintained this habit throughout his entire life, as he remained thoroughly unafraid of silence. Wherever he went, he kept a little notebook on him in order to write down any thoughts that popped into his head. When the wind stopped propelling his small sailboat, a hobby that he fell in love with in college, he would simply wait, pull out his notebook, and work on his formulas until the wind saw fit to carry him home. His first wife even became used to the fact that he would spontaneously pull out a marker and begin writing out scientific ideas on the shared tablecloth in the midst of a family dinner. Over time, he changed his major from math to theoretical science. It wasn't that he didn't enjoy arithmetic, but there were too many specialty options within the field. The physicist recalls finding himself in the position of Buridan's ass, unable to decide upon any specific bundle of hay to eat. He spoke glowingly of the education that he received after the switch, except for his physics course, which he viewed as hopelessly outdated. The newest theory that was making waves within the field had just been completed by Maxwell regarding electromagnetism. His work 30 years earlier had begun to answer questions regarding a number of natural phenomena while forming the basis for the discovery of radio waves. Despite its far-ranging effects, Clark informs us that it is hardly surprising that in this climate, Maxwell's theory of the electromagnetic field was not a part of the ordinary syllabus of a provincial European university. The reluctance of the more conservative men of science to acknowledge this revolutionary concept, marking a change from Newton's idea of forces operating at a distance to that of fields of force as fundamental variables, was no more surprising than any other human weakness for things as they are. For the embrace of Newtonian mechanics had continued for so long and was still so firm that those who either saw or suspected the fundamental incompatibility of Maxwell's theory with those long accepted ideas tended to look the other way. and above all, to avoid discussion of such a potentially disturbing subject. Einstein's greatest works would go on to obliterate Newton's explanation of the natural world. And due to his burgeoning obsession with his own questions about the Newtonian world, he was fully aware and supportive of Maxwell's work. This is where the independent spirit of Albert becomes key to his work. Another college kid may have raised his hand to ask about Maxwell's theory, but once shot down by the established professor, would have altered his ideas to comply with the teacher's established worldview. Albert, on the other hand, wouldn't budge on a subject on which he was convinced that he was correct. Professor Weber even told the young man to his face that Einstein had one fault, that he wouldn't allow anyone to tell him anything. Instead of conforming, Einstein once again took his education into his own hands. He studied the works of a number of scientists that I've never heard of in his spare time, often cutting class in order to concentrate on what he considered to be more important. One of his friends agreed to attend lectures in order to secure the notes that he would need to pass the exams. Rather than disappoint the young man, the ignorance of his superiors seemed to motivate Albert. Clark writes that the plodding insistence of Weber and his colleagues drove Einstein into reading and studying for himself. Einstein would have developed his original mind whatever happened, but the conformity of Weber, the pervasive air of a science learned for examination rather than for probing into the natural world, sped up the process. He found a kindred soul in the works of Ernst Mach. The Austrian's work led to an understanding regarding shock waves and the speed of sound. Like Einstein, Mach was fiercely devoted to skepticism, believing that all knowledge is a matter of flawed human senses. The so-called laws of nature, therefore, are human delusions, which can be updated or even altered based upon a more complete understanding. Secondly, Mach went directly after Newton, whose explanation of the natural world was the only accepted version of our reality. His criticism began with the terms used by the 17th century scientist, proclaiming that absolute space and absolute time couldn't be defined. Einstein's mind was so consumed by Mach's work that he grew to hate the necessities that came with college, namely the exams, recalling that during his senior year, the coercions had such a deteriorating effect upon me that after I passed the final examination, I found the consideration of any scientific problems distasteful to me for an entire year. Finishing with a 4.91 on a scale of 6, Einstein expected to be offered a low-level teaching position within the college's math department. This never came about, as Albert never understood the human element that goes into decision-making. His professors had absolutely hated being challenged by him as a student. They didn't want to be forced to work beside him. Plus, one of the keys to being a good teacher is to actually like class, something that for the better part of the decade had eluded the young man. Professor Gregory Pajansky writes that Einstein's anti-authoritarianism during his college years rubbed some of his professors the wrong way, and he had difficulty obtaining good references. This has resulted in the fictitious myth of Einstein working in splendid isolation during this time. And in a sense, Einstein was isolated from the heavy hitters in physics. However, this may have been a godsend, as those heavy hitters made discoveries that pointed towards relativity, but lacked the creativity Einstein possessed to put all of the pieces together. He began the post-college job hunt with zero prospects. He wrote to professors throughout Central Europe, practically begging them for an opportunity to prove himself. It was during this period that he acquired his Swiss citizenship. Unsure of an unemployed ex-German, the authorities personally interviewed him to make sure he was authentic in his desire to join them. Only upon receiving the honor did the young man become aware of their mandatory 3 months of military service as a requirement of citizenship. Such a condition might surprise some, but students of European history know that the Swiss were once rigid believers in military service, forming the core of numerous mercenary agencies across the continent. Einstein, however, was relieved of this particular burden after the services rejected him for having flat feet and varicose veins. He took another step towards full employment in 1901 when his first scientific paper was published. Another came when he served as an interim mathematics teacher during another man's mandatory period of military service. Although he had managed to get his flat foot in the door, he was unable to convince them to keep him on full time. He next tried to make ends meet by tutoring the children of the upper elite. Albert's first ward was a young English boy, but his tendencies towards minimum routine and minimum discipline meant that he was looking for work again within just a few months. A friend from his college days finally came through, helping Einstein secure a job within the Swiss Patent Office in December of 1901. The job hunt had been exhausting, and he had nearly failed to secure this opportunity, as he lacked the technical training necessary for the position. But throughout the entire process, he hadn't lost his legendary sense of humor, informing his friend that he was like a donkey, for when God created the ass, he gave him a thick skin. The patent office turned out to be the perfect job for a young Albert Einstein, although it forced him to have to move to the Swiss city of Bern in 1902. He would remain there for the next 7 years, dutifully completing his routine tasks while using his free time to focus his mind towards the things that really mattered to him. He received his doctorate based upon his work with differentiated equations while continuing to get his papers regularly published. Each work that he presented to the wider scientific community seemed to inch him closer towards relativity. From 1901 to 1904, Einstein labored to prove the physical existence of an atom. In other words, he was looking to create an acceptance of a reality apart from the direct visible truth. He wasn't alone in these endeavors, forming a group of scientifically inclined men and women that became known as the Olympia Academy. Although it was nice to have others to bounce his ideas off of, these weren't the scientific titans that Einstein would later work with. The members of the Olympia Academy would regularly get together and talk about the natural world. Their hypotheses and scientific papers that they read during walks through the city and hikes in the nearby foothills. A year into his new life, Albert married Mileva Marek, a friend from his college days. Marek was 4 years his elder and the daughter of a Slav peasant. Her low birth status hadn't stopped her from achieving her own PhD in physics, however. The nuptials occurred just a few months after the death of his father. Although the marriage would produce 2 children, Albert Einstein regretted his decision to wed. One friend reveals that the young man didn't quite know how he had even come to the decision to ask for her hand in marriage, perhaps believing that he had done so just because his parents had been against it. Another theory is that Albert felt as though he owed it to her, as the couple had given birth to a daughter out of wedlock. Little is known about the child, with some suspecting that they either gave her up to adoption or speculate that she may have died from scarlet fever. He likely believed that by getting married, he would be able to shift burdensome tasks such as meal prep and laundry services to his wife. The complication came in the fact that his wife wanted his attention. Clark writes bluntly that, in many ways, Einstein would in 1903 have been happier with a dedicated housekeeper. Instead, he tumbled into marriage almost by accident, possibly while thinking of more important things. He tried to be a good family man, but as he climbed the scientific ladder to fame, he simply didn't feel as though he could afford to make time for his family. His wife likely imagined that he would grow into the role, but had to have seen the warning signs when, rather than a honeymoon, they went to a local restaurant before walking to their new shared home together, only to discover that the absent-minded groom had forgotten the house key. By the end of the year, their son, Hans Albert, was born. The new father continued publishing papers, but found it difficult to catch the eye of the established elites, as his work was almost entirely theoretical. His methods were totally mental, with him claiming that he just needed a desk, some pads, a pencil, and a large basket to hold all my mistakes. Clark explains that Einstein believed that theories into which facts were later seen to fit were more likely to stand the test of time than theories constructed entirely from experimental evidence. The theories that interested him the most at this moment happened to all be about light. Despite being literally surrounded by it, the scientific understanding of light was limited. The ancient Greeks believed that it was comprised of minute grains in rapid movement. In the 1600s, it was proven that light consisted of waves that traveled the unseen ether that permeated all space. At the beginning of the 20th century, Max Planck introduced the Planck constant, which gave greater mathematical understanding to the transference of energy. It was the breakthrough that would eventually lead to quantum mechanics. He claimed that it was a discovery as important as that of Newton. Wikipedia, which is a far better source than most believe, explains the importance of Planck's breakthrough to Einstein's work, noting that before Einstein's 1905 paper, electromagnetic radiation such as visible light was considered to behave as a wave. Hence the use of the terms frequency and wavelength to characterize different types of radiation. The energy transferred by the wave in a given time is called its intensity. The light from a theater spotlight is more intense than the light from a domestic light bulb. That is to say that the spotlight gives out more energy per unit time and per unit space, and hence consumes more electricity than the ordinary bulb, even though the color of the light might be very similar. Other waves, such as sound or the waves crashing against the seafront, also have their intensity. However, the energy account of the photoelectric effect did not seem to agree with the wave description of light. The contradiction discovered by Einstein was that not all light traveled with the same intensity. Clark writes that no one had up till now thought of asking the awkward questions which the contradiction begged, or if they had thought of it, they had not dared. Einstein both thought and dared. Their prior explanations had been stunted by religion, a belief that randomness was just an example of God playing dice with the world. But Einstein wasn't willing to accept such a conclusion. In his mind, light at some times ought to be regarded as a stream of particles, the way that the Greeks had envisioned it. But at other times, light must be regarded as Newton had, with light operating as a wave motion. Depending on the situation, it behaved differently. He outlined his hypothesis in his 1905 paper entitled On the Electrodynamics of Moving Bodies. The finding, which is known as the special theory of relativity, wasn't immediately accepted, with the Times of London claiming that the 9,000-word paper was an affront to common sense. The YouTube series Crash Course uses a hypothetical train traveling at half the speed of light within a vacuum to explain the purpose of the theory. Now attach a headlight to the front of that train, which is pushing light towards an individual waiting for the train. The fact that it is attached to a moving vehicle should mean that the light is coming out at 1.5 times the speed of light. But it doesn't. Instead, it simply continues to move at 1 times the speed of light. This proves to be true for any vantage point, from someone aboard the moving train as well as for an individual standing still on the arrival platform. In all other instances of physics, speed multiplied by time equals distance. Yet light is always constant. Since it always stays the same, time dilation and length contraction become a thing, and connecting them paints us a picture of a 4-dimensional space-time. There is no longer any controversy regarding the work of special relativity, but there was plenty of it in 1905, foremost of which was who to apply credit to. Einstein claimed that the theory was entirely a work of his own, yet numerous scientists across Europe were simultaneously inching closer to the conclusions that he presented. By not crediting the work of others, he made it appear as though he was the only one working towards his world-altering conclusions. The conversation notes that although there is no doubting Einstein's genius in formulating special relativity, it is generally accepted that had Einstein not published the theory in 1905, some other physicist would have done so shortly thereafter. The physicist himself would admit 40 years later that there is no doubt that the special theory of relativity, if we regard its development in retrospective, was ripe for discovery in 1905. The fact that it was published by a relative unknown caused many to reject his ideas on face value. After all, his paper didn't meet scientific standards of the time, containing literally no footnotes or references. The idea also remains hard for anybody to come to grips with. Bertrand Russell, a British philosopher, points out that everyone knows that if you are on an escalator, you reach the top sooner if you walk up than if you stand still. But if the escalator moved with the velocity of light, you would reach the top at exactly the same moment, whether you walked or stood still. It wasn't an immediate hit, and didn't manage to win the Nobel Prize until 1921, 16 years after Albert Einstein submitted his theory to the scrutiny of the wider scientific public. Once it did achieve recognition, however, it changed man's relationship with his physical world in 3 ways. Clark writes that the first way, and possibly the least important, is that it has helped him to understand some phenomenon which would otherwise have been incomprehensible. We use it, Oppenheimer has said of special relativity, literally in every branch of nuclear physics, and in many branches of atomic physics, and in all branches of physics dealing with the fundamental particles. In addition to supplying this very practical tool, relativity has enabled man to give him more accurate, more descriptive accounts of the world of which he is a part. As Philip Frank has pointed out, the plain statement that a table is 3 foot long is not only incomplete, but meaningless when compared with the statement that it is 3 feet long relative to the room in which it stands. Relativism, he says, means the introduction of a richer language which allows us to meet adequately the requirements of the enriched experience. We are now able to cover these new facts by plain and direct words, and to come one step nearer to what one may call the plain truth about the universe. It is this plain truth about the universe which suggests the third and most important change that relativity has produced. Its epistemological implications are still hotly debated. Nevertheless, it is indisputable that while the theory has enabled man to describe his position in the universe with greater accuracy, it has also thrown into higher relief the limitations of his own personal experiences, redirecting science to look at nature from the viewpoint of a man, rather than from the viewpoint of an angel. his paper sanctioned him to begin rubbing elbows with Europe's scientific elite. But as Clark notes, other men in the arts, as well as in science and politics and in war, had sent up sparks of genius during their early years, yet failed to set the world ablaze. To make room for the Lorentzes, Plancks, and Machs of the world, Albert Einstein sacrificed his family, once absent-mindedly noting that "my wife has returned yesterday from Serbia, where she was on holiday with both of the children. Do you know what the result is?" he asked a professor. "They've turned Catholic." "Well, it's all the same to me." This obsessional concentration was a key to his character, as he would not let an idea depart without him carefully examining it from every possible angle. Although his hobbies of music and sailing seemed to be healthy alternatives designed to ensure a successful work-life balance, each served the purpose of helping the physicist labor through whatever Gordian knot of equations he was focused upon at the moment. Music helped him get his mind unstuck, while sailing allowed him enough distance to think devoid of distraction. He had to constantly work, for as Clark writes, it is clear that during the year immediately following 1905, the concept of relativity percolated slowly through accepted ideas like rain through limestone, rather than breaking them down like the weight of water cracking a dam. But as water slowly penetrates the myriad channels, so did the special theory begin to affect the whole body of physics. The delay was caused in part due to the fact that the technology needed to prove the theory hadn't yet been invented. Einstein was unique in his belief that a theory without proof was perfectly satisfactory, if it were sound. That thought wasn't shared by the vast majority of his peers. Additionally, it was hard for some to believe that an earth-shattering revelation on the level of Copernicus or Newton would emerge from a person working as a mere patent clerk. Due to his limited finances and the requirements of his 9-to-5 job, those interested in his ideas, more often than not, had to come to him. While still working on questions related to the theory of relativity, Albert began to focus on radioactivity and the movements of atom molecules. He approached the problem of a coin flipping, discussing how if you had every single measurement, mass, velocity, etc., then you should be able to 100% identify which side it will land on. The inability to come up with such a calculus equation would prove to most of us the existence of luck. As you might expect, Einstein saw the problem differently, arguing that the inability to calculate such a thing just meant that they were missing some unseen force that hadn't yet been accounted for. Throwing out the laws of nature, the physicists claimed that there must be more to atoms, even though they lacked a way to prove it. Decades later, scientists would prove that at the atomic level, the laws of cause and effect do give way to the laws of chance. Unsurprisingly, Einstein refused to accept any conclusion that made it appear as though God played dice with the world. In 1907, the professor who pushed through his PhD encouraged him to apply for a gig as an assistant professor, a prerequisite to eventually obtaining a full professorship in Switzerland. Sadly, his application was rejected because he hadn't filled in enough information. The lazy dog lying within the genius had once again reared his ugly head. In 1908, however, his appointment was pushed through, and at the robust age of 29, Albert Einstein finally got the job that his degree had prepared him for. He chose the theory of radiation as his course's topic and delivered his first lecture to the 4 students that had signed up. His course load was so low that he was able to continue working at the patent office on the side. Word of mouth about the absent-minded professor soon spread, and during the second semester, Einstein taught just one student from within the confines of his small home. The complete lack of student interest would get most professors fired, but Einstein's stature grew while he was teaching due to the uncoordinated efforts of others who were fiercely wrestling with his theory of special relativity. Eventually, mathematicians added the infamous E equals mc squared to help bring his work closer to the practical realm. Their work resulted in him considering the accepted forces of nature of gravity and inertia. It is harder to throw a cannonball than a tennis ball, but as it has been proven within a vacuum, gravity affects the two in the exact same manner. Einstein pondered why gravity didn't affect the heavier, faster-moving object differently. Clerk tells us that the explanation proposed by Newton for this curious exception to his laws of inertia was ingenious. To Einstein, it was too ingenious. The explanation was that gravity, reaching up into the heavens to attract material objects down to Earth, exercised its power precisely in proportion to the mass concerned. On objects of small mass, the pull was relatively small. On those of greater mass, the pull was increased, to just the extent needed to bring them all down towards the ground at the accelerating speed of 32 feet per second. Thus, the force of gravity operated so that it always counterbalanced inertia, a proposition which Einstein found very hard to take for granted. The more he considered his predecessor's thoughts on inertia, the less he liked it. It was an accident of nature that he considered too odd to be truly accidental, a lucky chance which he felt must be the result of something more than just luck. In Einstein's thought experiment on the subject, a man falls through an elevator shaft in a closed box when he takes out his keys and wallet. Doing so would cause them to fall at the exact same speed if they were beyond the pull of gravity. Clark next explains the genius moment by asking, but what would happen if one thought instead in terms of light? Here it was necessary to change the thought experiment. Once again, there was a closed box. But this time, instead of dropped keys and money, it was necessary to envision a ray of light crossing the box from one side to the other while the box was being accelerated. The far side of the box would have moved upwards before the ray of light reached it. The walls would be hit by the light ray nearer the floor than the point at which it set out. In other words, to the man in the box, there would have apparently been a bend in the horizontal ray of light. The result of the thought experiment only produced more questions, and after 12 years of thinking about it, Einstein produced his 1919 general theory. Interestingly, the mathematical work of Nobel Prize winner Hermann Minkowski was essential to the development of the general theory. Minkowski had been the professor who had referred to his former student as a, quote, lazy dog. It is in this theory that time fully becomes a fourth dimension. In the interim period between Einstein's special theory on relativity and his groundbreaking general theory, he received an honorary doctorate. Hilariously, he had assumed that the invitation for the ceremony was a run-of-the-mill advertisement and had crumbled it up. The follow-up as to the lack of a response finally got him to Geneva to accept the award, which he did so wearing his traditional informal attire, including a straw hat. He was now consistently being invited to present at major scientific conferences. Science began taking up so much of his life that he finally left the cushy, safe job at the patent office in order to become a full-time assistant professor at the age of 30. Accolades in this world, however, still eluded him, with word soon spreading that his students couldn't understand any of the complex ideas that he was lecturing them on. Name recognition alone ensured that another opportunity was always within his reach. Bouncing from university to university, Clark writes that, Einstein had at last officially broken through into the academic world, and the future seemed plain sailing. The prospect was of a placid life at one or possibly two Swiss universities. Yet the professor never managed to understand the irrefutable natural law of happy wife, happy life. Mileva hated each move, as none of them settled her husband to the point that he could spend more time with their growing family, as Hans Albert was joined by his little brother Eduard in 1910. Rather than settling into their new idyllic life, Einstein uprooted his family, jumping at the opportunity to teach in Prague at the grounds of Ernst Mach, the man whose own work had meant so much to Albert's own. Because he was so focused on the scientific world, he walked into his appointment in Prague completely blind to the political undertones that had already begun in the German-adjacent lands. He even accepted the citizenship of Austro-Hungary in order to satisfy the job requirements. The increase in pay was substantial, allowing the family to hire a live-in maid for the first time. The standard of living was also increased, switching their reading lamps from oil to electricity. From the beginning, he claimed to be having a good time in Prague, even though life is not so pleasant in Switzerland. He continues saying, "Apart from the fact that I am an alien, there is no water here that one can drink without it being boiled. The population for the most part speaks no German and is strongly anti-German. The students too are not so intelligent and industrious as in Switzerland, but I have a fine institute with a magnificent library." That is truly a wonderful way for a friend to tell you that his move went well. But for Albert Einstein, the last part was key. As long as he had a magnificent library to advance his scientific work, he was content to put up with all of the rest. His wife, however, wasn't prepared to boil her water before drinking it. While her husband was ingratiating himself with the city's substantial Jewish population, she was finding it hard to contain the resentful and bitter feelings that she had developed towards her husband. She had trouble adapting, never learning to speak the language, and as a result, the couple began to constantly fight. The end result was his premature departure from Prague in 1912 for a new post back in Zurich. He had other options, including an invite from the United States for a 4 to 6 weeks guest lecturer tour. But he chose a life that was familiar to him. His new university gave him some freedom to lecture when he chose to, which Clark tells us that years afterwards his students recalled him standing in a snowstorm under a lamp at the foot of the Zurkberg Mountains, handing his umbrella to a companion and jotting down formulas for 10 minutes as the snowflakes fell on his notebook. For when Einstein wished, he could speak of basic metaphysical concepts such as time or space as matter-of-factly as others speak of sandwiches or potatoes. Elite physicists, including Marie Curie, regularly visited him, listening as he explained his newest revolutionary thought that gravity might bend light while it is moving at a constant. Not everyone was impressed, however, with one research student recalling seeing an engineering professor being horrified by what Einstein was saying, while others walked out in a rage, proclaiming that what he was selling was absolute nonsense. In 1913, a physicist named Bohr introduced theories which better identified the atom, recognizing that there were unknown causes lying behind their movements, which was something that Einstein had theorized earlier when he was imagining predicting the result of a flip of a coin. Everything was coming up roses for the absent-minded professor, who from time to time still forgot his keys, neglected bringing his wallet to dinner, and didn't know the first thing about helping out with the household chores. Fatefully, he decided to make one more move in the name of advancing science at the expense of the rest of his well-being. In 1914, he would return to the nation which, as a 16-year-old, he had renounced, taking up a job in Berlin, Germany, that would allow him unlimited time and money with which to permanently change the course of human history. The world would indeed change in 1914, but it wasn't because of the work of Albert Einstein. That change came about due to the actions of Princeps, a member of the Serbian terrorist organization, the Black Hand, whose assassination of the heir to the Austrian-Hungarian throne would plunge Europe into darkness. Berlin, Einstein's new home, would be at the center of the chaos, which saw his beloved science turn against humanity. I hope you enjoyed today's episode. If you want to interact with the show, you can email us at resourcesbylowery@gmail.com or contacting EmpiresPod on Bluesky. If you would like to financially support the show, please look in the description for more information. As always, thank you for listening, rating the show, and spreading the word.